What's up, Tube? Welcome to Low Guido's Chop Shop, the second best Geo Blaster battle mech channel on the tubes. Today I'm continuing with the battle mech. What I am continuing with is the electronics of the mech. So first of all, it is going to be powered by an Arduino, which this one's a Mega 2560. If you're not familiar with Arduino, it's basically a programmable microprocessor dev board that you can just code up and get it to do stuff that you want it to do. If you don't know about Arduino, you should look into it. It's fun. It's good to learn. It's got a USB port on it here. You can just plug the USB into your PC and download the code and make it do fun stuff. Anyway, this one being the Mega, it's got lots of inputs and outputs, so that'll come in handy. And also, I've got some proto boards. I bought like a bag of proto boards, like so many, more than I need, but it was like AliExpress bulk bargain. I just bought a bulk bag of them. You can actually buy proto boards that are already been pinned, that they plug into the Arduino, but I'm just gonna cut these up and make my own boards up. The other thing you can also do is, if you got like Protel or something, you can design your own circuit board, send it off to PCBWay and get them to knock it out for you. That's easy to do as well. Just zoomed in a bit for you so you could get a better view of what's going on here. Essentially, I'm going to use some of these proto boards. Probably just those ones probably just that one, to be honest, is all I really need. Maybe some other ones if I decide to add some more things. I'll cut this one in half and be using this to connect all the pins for the servos, because there's 18 servo motors. Each one's got 3 pins, so I'll just line them up all in here. I'll probably cut this in half, so I've got 3 on this side. Oh well, 3. I say 3. 9. So I've got 9 on this side and 9 on that side. 3 legs on each side, and then yeah, let's go. Let's just open the thing and let them cop it. I'm probably just going to cut this in half. Breathing protection, eye protection, ear protection, all that. Alright, so I got this guy here, and I got a bunch of header pins, and basically they're gonna all get soldered into here, and they're going to become the connection points for all the servo motor connections. And one of the things I'm going to do to make soldering these a heap easier is I'm just going to get them and I'm going to put them into a female, put 1 pin of each into a female header, and that way they'll all be lined up perfectly and neatly, and when I put it into the board I'm not going to have any problems with the things falling out, like just demonstrated. So now I'll just be able to pop them in here and then solder them in underneath, and they'll all be lined up. Won't have to worry about anything pretty much. Once I've just got a bit of solder on one of them, then the rest of them should all just be perfectly lined up. So I'm just going to get my little helping hand clamp in here just to hold that up while I solder it. Right, so I'm just going to put a touch of solder on this one, just a touch on this one. Now the nature of this these servo connectors, basically the middle of every single one of them, the middle pin is positive. The outside pin to the left is negative. I guess left is relevant to where you're standing at the time, but in my case it's left. And the pins on the right, each one of them will be the signal pins. So because all of these are going to be negative and all of these are going to be positive, what I'm going to do is I'm actually going to run a wire across all of these pins and all of these pins back to this little tab here. So I'm just going to whack a little bit of solder on those bits there, and have those guys ready to go, and then I'll solder a little bit of wire to every single one of those pins. I'll probably do the middle row first, just because I think it's going to be harder to get to once it's done. Yeah, that's what I reckon. It's just going to be easier to get in here now. While there's no connections in here. Quite difficult trying to film this and not get in the shot and see what I'm doing as well. Alright, the good thing is, because all these are joined, you don't have to worry about shorting them out, because they are all shorted by nature. Alright. This thing would stop wiggling, I'd have half a chance. Alright. Now just do the same on the other side. Alright, so not my finest work, but they're all nice and straight and even, and they're all soldered on there. So you've got the two main power rails, the positive and the negative. Now each one of these individual signal wires is going to break out to one of these. There's going to be the wires coming out of here, which will go to the microcontroller. I'm also going to drill out these a couple of these holes so that they've got like mounting holes to mount onto the board. Alright, so those holes should be the perfect size for the little self tappers that I've got. Excellent. Couple of them in there. These tiny screws. Every time I pick one up I drop it, without fail. Alright, and here's one I prepared earlier. Same deal. Same deal but opposite. One's for the left side and one's for the right side. Like that. Should probably put them actually on camera. Alright, just going to work on getting the wires connected to these signal pins now. Alright, now I've got my rainbow cable, and what I'm going to do is I'm going to try and feed up each strand. This will be well worth watching. Feed each strand through the hole. There we go. Solder it in and sort of bend it over like that, and also solder it to the pin. That makes sense? Alright, I'll do one and see how I go. Do one there. And I'll sort of bend it over. Also going to solder it to this pin. Now this pin is the one pin that I already soldered, so it's already got some solder on it. There we go. Alright, I might as well just put some solder on this one too, why not? I mean, we're here. It's all the same. Alright. That's one. I'm going to do that. I'll do that 8 more times. Alright, there we go. I got all the signal wires soldered in now. Each one going to each one of those pins. And the other end, got some pins that will plug into the microprocessor, the Arduino. Alright, I'm going to do the other side. Alright, after a little bit of soldering, we have two matching equal but opposite servo boards. You'll notice I did do them opposite so that they will be one on each side, and they will both face forward, and they'll have the main power wires coming in from the forward side. Whether that matters or not is, well, it doesn't. Purely aesthetic. Purely aesthetic. Just because I like it that way. So, ironically, the wires that I've just cut here were terminated with a little pin, which is specifically designed to connect into the Arduino that I'm using. However, the length of it is huge. It's huge. It doesn't give a lot of space at the top, so I think what I'm actually going to do is I'm just going to re-terminate all of these with the same sort of header pins that are on this, and that way they don't stick up too far and they will plug into the headers on the Arduino like that, and it'll be nice and short, as opposed to these ones which stick up a mile. Great for prototyping, but I don't want to have this sticking up, so I'm going to terminate these with header pins. The top plate's got these little standoffs here, which are for mounting the Arduino board onto. It's been designed for that purpose, so I'm just going to temporarily chuck a couple of screws in here for the purpose of lining a few things up. Of course, I drop those screws every time. You might even notice as well, I don't know if you can see, the gold underneath. I've printed out a stand, which is good for just working on these things. That's this one underneath here. So I'm soldering some of these, or at least connecting or cutting the lengths of these in situ. I've just placed them where they're going to be going, because I don't want too much forestry going on here. I just want enough connection to get to the pin, and then that's it. So I'm just sort of lining them up, measuring to length, and then cutting them and soldering them on there. Now, of course, I've pre-positioned heat shrink on each of these cables, so everything's ready to go. So there won't be any issues with heat shrink. Now, ideally, you probably shouldn't be soldering these in situ, but it is what it is. Alright. Now I can pull that out. I can snap this Oh, yeah, that'd be right, wouldn't it? Snaps where I don't want it to snap. Alright, now that I've got them all cut to length and soldered, get the heat shrunk. And while the heat shrink is still warm, I just want to manipulate them into position. They're gonna go like that. So when the heat shrink dries, it will cool. Whatever heat shrink does, it cools. It doesn't dry. So when that cools, it'll be in the shape that I want it to be. Incidentally, on this particular board, two of the inputs are over here, and the rest of them are all in line. That's why there's a separate little header for those two. Alright, now assuming all that is in the right spot and the right length, they should nicely, neatly plug in here. So these ones all here and those two there, and then this should sit perfectly there, and there is screw holes or screw posts right there to mount this little board, so that fits perfectly and lines up with the mounting posts there, wherever they are. There. Don't mind me. Perfect. Alright, now all the servo connectors have got a place to go, at least for this side. Then I just got to do the same thing on the other side. Now the one on this other side might actually be a little bit easier to line up, because all of the wires are in one row instead of utilizing some of these ports over here. I imagine that if there was enough digital input outputs in one line, or outputs in this case, because they're the output of the if there was enough in one line, then they'd just all be in one line. But either way, whatever. There's a couple around the corner there, so this should be relatively straightforward because they're all in a row. So I think I might be able to just do most of these the same length. So the first one is, I think, the crucial one. It's going to be that long, and after that they're all probably going to be about the same. So I should be able to sort of mark these off and just sort of check them. Yeah, they're about the same. So I mean they're going to be a little bit longer by the time I get to the end. So the last one, which is the black one, the black wire, will be that long. Yeah, so I just line them all up and sort of take a diagonal line from there to there. I should be pretty sweet. Okay, let's see how well my diagonal cut theory worked. That seems to have worked quite well. Yes, perfect. Not bad at all. There we go. Nice and neat. I like it. That's cool. I'm happy with how that's turned out. Alright, among my box of bits is a SBEC, or switched battery eliminator circuit, which is a dumb way of saying it's a transformer. Basically, we have battery voltage coming in here, and then servo voltage coming out, and this one is it's got a little jumper pin on the end here so that you can actually adjust the voltage. This one does 5.5, 6, 7 or 9 volts. I've got it set to 6 volts currently. I believe that is what my servo motor's like. And I'm actually just going to cut this shrink wrap off, because it is just shrink wrapped, and I've 3D printed a nice little container for it to go into. That's part of the files that are on the Thingiverse link that I will have in the description of this video, and I will just work on getting the scissors through this shrink wrap, and then I'll mount it inside this little case. I'll probably have to remove these desolder these power wires here and then solder them back on again, so it's probably worth noting which side is which. Positive lines up with the positive and negative lines up with the negative, so it all makes sense. I've got a XT60 connector on the end of here, which is because I was using it earlier on to test the servos. You might have noticed in the last video. I will just take that off. I'll probably still use the XT60 just because it's convenient and I've got heaps of them. But I want to cut these wires to length, and I want them to go through these little holes. So the holes that have been set up in the print there. So I'll do that. Get this sussed. Probably would have been easier with a knife. Yeah, right. Finally. Alright, so that should now go nicely in there, although I will have to thread the wires through the holes, so I'll do that. Alright, just gonna desolder these wires. If you are going to do this, it pays to have a fat tip, because these wires do soak up quite a bit of the heat. And now I'm just gonna, I've already taken the XT60 off there. There's plenty of length in these wires, so take that off, and then fit this in to this container. Alright, this is a very tight fit in this container, so I think what I'm going to do, feed these wires through, connect them up first, and then feed it in. So I'm going to need this one, soldered there, and this one soldered here. Now there was 2 wires originally connected to this SBEC, so you could run, I guess, 2 different servos or something. I'm just dropping it to the one because I only really need the one power connection, and then that's going to tee off on the next bit. So now if I push this in here and sort of feed these wires through, hopefully. Okay. Alright, so as I feed and alright, nice, very snug, form-fitting. That's good. That's nice, and might need to go a little touch higher because that cap on the bottom of the board is still protruding. And this board, I think, is designed to friction fit this in. Alright. Nice. Okay. Now I'm going to mount the S-Bec. S-Bec. What a stupid name. S-Bec. Just temporarily, I think, here. It might, who knows, these temporary mountings might become permanent. I mean, nothing's permanent. You can always just undo the screw using the little self-tappers, the what I've actually found out to be the actual 6mm M2.5 or something. I don't know. The self-tapping ones, the small self-tappers. I'm going to run these main cables down through this hole, because the battery will eventually live underneath here. And you may or may not have noticed off camera I did run some bus lines between the two servo connector boards, because well, they've got to be joined together. It was just this exact moment that I realised that the S-Bec originally came with two servo plugs that I cut off, which is these ones, and it's occurred to me that while the way I'm doing this was probably going to end up looking a bit neater with wiring, it would have been a whole lot easier just to have another header pin, just one more, soldered in here, and then just plug the two of them in, one in each port. Would have saved me a bit of soldering and mucking about. But it's not about that, is it? It's about making it all nice and neat. So I think I'm just going to cut this one to length here. And positive one as well. I'm just going to solder them in place there, and they will also be connected to that side. So that's going to be the power unit to power all the servos. And you may, or if you're very keen-eyed, you may notice I've installed one of these cable management things. I printed off a whole bunch of these little rings for cable management. So basically I'm going to put one on each of the servo motors so that I can run these leads through the ring and just have a little bit of cable management there, so it's not a massive rat's nest of servo cables, because it's going to get wild once I start plugging all the servo cables in here. Just a bit of a close-up of what just happened here, in case you missed it from that wide angle shot. Got Got the power from the S-Spec going in to power all the servo boards now. And what's next? I might plug in these servo wires, hey? I'm just going to install these cable management rings before I plug anything in, and I'm replacing the short screws here with a longer one. Because obviously I need a little bit longer to hold the little cable management tab, but also because I was a little bit short on short screws. I was a bit short on shorts, so I got heaps of the long ones left. I was just looking at this, seeing if that was going to obscure the power plug there, but then I just realised I'm not going to actually be using that power plug anyway, so it doesn't really matter. The USB, however, I will, because I need to load the sketch, so that will, but yeah, that power is not needed. Look, here's one I've pre-placed. There we go. It's handy. I don't even have to put that through because I've already done it. Now I'm not sure what I'm going to do. Obviously, because the servos are in different places, each set is 3 different lengths, so they're not going to be equal when I get to the thing. So I'm thinking maybe I might shorten the longer ones when necessary. I also want to leave some slack, obviously, for the leg movement, because I don't want to have it tugging on the wires really tightly when it moves. So I might just leave them long until I've programmed it up and gone through the full motions of the legs, and then after I've done that, I will shorten them to length. If necessary. May not be necessary. There's a very high chance that it won't be necessary, but you know. Alright, that is all of those cable management rings. All conveniently sized to fit servo connectors through. Alright, now with these legs, they're actually numbered 1, 2, 3, 4, 5, 6 in that order, and then 1, 2, 3 steppers. So, having said that, they should all plug in order, because all of the pins on the circuit boards and all of the input outputs are all in order. So it should go 1, 2, 3, 1, 2, 3 like that. So it should just be a matter of plugging them all in a line, and they should go, hopefully. So this will be one. And this will be 2. This will be 3. Now, it might be worth noting, not really, but whoever came up with the design for servo motor wires, I mean, they've been around for a long time. They've been around since the dawn of remote control cars and planes and stuff. Whoever came up with the idea obviously decided it would be a good idea to put the positive wire in the middle. That way you can't mess it up if you plug it in the wrong way. The worst case scenario is that you could accidentally you could ground your signal wire, which isn't really it's not the worst outcome. So obviously they thought that through when they were designing the wiring layout for servo motors or servo wires, the plugs. I like that the positive's in the middle. Either way, you got a negative either side. Well, you got a negative one side and a signal the other side, and no harm if you do accidentally ground your signal. Alright, so that's 2. Okay, that's 1. That's 2. And that is 3. And then it's just going to be a matter of doing the same thing on the other side. Last one here. Alright, cool. Just going to pull a bit of the slack back into the leg area so it's not all up there. There we go. We'll deal with that. Alright, I've just taken the Arduino off of the chassis for a moment here because I want to access the bottom of it. Oh well, I want to access the underneath of the where the Arduino is sitting, just because I want to feed through a Velcro strap, so that I can use it to strap the batteries in. What I'm actually going to do, because this one's got a loop on it, I'll probably just cut the loop off, but for now, put that through there, and then that down through there, and then that will give me a start. This strap's way too long, so I'm going to have to cut it short anyway, but at least with it in position there, when the Arduino goes back into place, I will have the strap under there ready to go. Alright, so the next thing I want to do here is terminate these battery wires. Now the battery is going to be, I'm going to use a big 3S LiPo, Turnigy or something. I got heaps of them, so why not? Here's one. And this is going to live in the bottom of this bad boy here somewhere. So I'm going to need some Velcro straps. There's some slots in this body here and here, which is obviously for Velcro straps for the battery. Actually, these batteries I've shortened the fly lead coming off the battery, so that might actually work. That might actually work to benefit me in the length I put on these. Maybe I was thinking maybe if I put the battery this way and have the leads pointing back. I have the leads like that, then I can run the power wire up here. The other thing is this power wire is going to have to power the Arduino as well, so what I'm going to have to do is probably run a connector in there, and then I'll run some more wires up from this side, I think, because I've got to run to the power and ground is here, these two pins here, so I'll run them up from underneath and then up here, and then I'll just terminate them on a pair of those header pins that I've had from earlier on. Probably this one will do. Just break off two of them, and I'll use my power and ground there. Now the original design shows he's got a little voltage divider circuit that comes off and goes into one of these analog inputs and reads the battery voltage and lights up a whole bunch of LEDs here. I'm probably just not going to bother doing that at this point in time, at least not yet. I mean, the option's there, I guess, if I want to, but for now I'm just going to leave that voltage divider alone. He does have a little a diode on the input, which I think is necessary. I'll wire that up. I'll terminate this with an XT60 just because I've got tons of them, and we'll go from there. Actually, looking ahead a bit, I'm thinking that I'm gonna have to, for the receiver, So I'll probably make a little board that goes on top here, and I'll probably run these power leads up to the board and then get across to the power pins over this board, which I will cut to size. So I'll do that as well. I'm still waiting for my PS2 controller to arrive, so not rushing to do that yet. But what I will do is I'll get these wires terminated with the XT60 here, and then I'll look to running these up somehow, rather than going directly wired into here. I'll probably work on this little circuit board. Alright, so to make my little proto board to size, I've cut it. I've gone one hole either side bigger than the width of the Arduino, and I'm going to pop a 4-pin header in in inputs 2, 3, 4 and 5, PWM inputs, yeah. And on the other side I've got a 7-pin header, which I'm going to take from analog in 0 through to 3.3 volt in, and the reason I'm doing that is for future, if I do want to use the if I want to implement the voltage divider, then I'll probably I'll have that pinned up ready to go, so I don't have to change my board if I do change my mind later on and I want to have that in. So what I'm going to do is I'll line that up there. That will fit nicely there, and I'll just solder these pins that are there. Alright, let's see if I can tuck these out of the way for a bit, enough to get my iron in there, and I'll just roll through here. Alright, and I'll do the same on the 4 pins on the other side here. 4 pins? Yes, it's only 4 pins. Alright, good to go. Oh. Get those wires out of the way. There we go, so they're ready to go, plus I've got an extra row on either side for adding on wires and stuff, and that can just plug in when it's ready to roll. Easy. So I've got a diode, the 1N4007, which is the same diode that I actually had hundreds of these. It's the same diode I use for putting the mag priming circuit into blasters that don't have a mag priming circuit. Simple diode. That one there is going to be going in here, which is going to be the voltage input there on that 3rd pin down. So I'll mount that in there, solder it in place. Right, so I'm just going to put a dab of solder on this here, just to hold it in position, not so much to actually fix it in place, but just to hold it there while I solder on this tab. Now this is gonna be the VN VN. Alright, now that that's held in there, I'll properly solder that and I'll flip it. And I'll properly solder the other side as well. It's actually unnecessary to solder both sides, but I just like doing it. And that excess will trim. And this diode, in case you're wondering, is just a one-way valve for electronics, basically. Just means that current can go one way but not the other way, and that's why I use it in the mag priming circuit. Now these next two pins here are both ground, so I'm actually going to take one of the offcuts of the diode that we just soldered in. I'm just going to use it, bend it, and I'm going to use it to connect to the ground. I'll probably trim it a bit. Doesn't need to be that long. Yeah, that's sufficient. And again, I'll just put like a tiny dab of solder just to get it held in place. Whoa! Don't hold the other end when you're soldering it. I thought I'd be quick enough that I wouldn't burn myself, but I was wrong. Alright, so now I've got that one there connected to the pin next to it, which is going to be the for my ground, for my power in. So I'm going to have my voltage in and my power in here. These proto boards, I haven't used these proto boards before. The ones that I'm used to using, all these rows are connected. So these ones are like each individual little dot is an individual little dot. So I don't really see the purpose. Like you got to run wires between them. I don't get it. Anyway, I like the other ones better. These ones look cool. They've got a nice green solder mask and everything, but the other ones that I used to use they were all rows, and you just basically cut the section you didn't want, like you drill out one of the holes or something. Much easier. Anyway, jabbering on. Now, the whole reason that I'm building this little board here is because I think I'm probably going to need to use this logic level converter chip. I imagine I'm going to have to convert it to 3 volts and vice versa, just to make sure that everything's happy, I guess. Don't want to go blowing anything up. So just touched a little tab of solder on there just to hold the board in place while I get the actual soldering done. Alright, eventually these high volt ends are going to connect to these pins here. So I've got the 4 signal pins that are going to be the inputs to the Arduino. Let's flip that around. There's the board. So I've soldered some. I've basically broken up some of these headers and soldered a couple of headers on here, and I've bent them down a bit just to keep the thing low profile, because I want to have something sitting fairly close over the top of this, the platform to mount the turret. So I'm a bit sort of pressed for space, I guess, if I wanted to plug some pins in here. I kind of don't want them sticking straight up because yeah, I want to keep that headspace for a minimum, to a minimum. I've also added another pin here, and I've added these wires here, which is for the power. I'm not sure if this is how you're supposed to do it, but this is how I've done it. I've never used these boards with just the holes. Usually the boards I use have strips. Anyway, so yeah, I've added another pin here, which is currently not connected to anything. So there's, I guess, expansion space here for the, put a couple of resistors here for the voltage divider if I want to do the voltage divider circuit later on. Plus I've put a pin here because I think I might use that output to trigger the turret, perhaps. I'll put it there anyway, just for future proofing, I guess. The reason I've got this, I don't know if I explained it properly before. The reason I've got this is a low level to high level converter. It converts from 3.3 volts to 5 volts. The Arduino works on 5 volts, and I'm going to be using a PlayStation 2 controller to control the thing, and the PlayStation controller runs on 3.3 volts generally, and some will work on 5 volts and some won't, from what I understand. And I have this controller here, and I've been having nothing but trouble with it, and I think the controller itself is faulty, so I've ordered another controller. Hopefully that should be here today. I've been dicking around with this one for quite a while, trying to get it to work, and it's a wireless, so it has a receiver dongle, which is going to plug in here, these 4 pins here. That's what that's for, 4 pins there for the receiver. Then it converts to 5 volts before going into the Arduino through those 4 pins there. I dicked around with this controller for way too long, and I tried so many different things with the receiver, the little receiver chip. I've soldered and unsoldered and resoldered and unsoldered the chip so many times that the pads are actually coming off. The pads are coming off the circuit board. This is the receiver here, so it's looking real ugly right now, and I could never get this thing to connect to this thing. So I don't think it's an issue so much with any of the electronics as much as it is an issue with this talking to this. There's some sort of, like, when you turn this on, it flashes like it's trying to connect, and my understanding is that it should flash like that till it connects and then go solid. Being that I bought this off AliExpress with absolutely no documentation, no instruction manual or anything, I'm only making assumptions from what I know about PlayStation controllers. Generally when it's flashing, it's trying to connect, and it was just continually flashing forever, and it was never coming up with a solid light. So I'm assuming something's wrong there with the connection, not necessarily the not necessarily this portion of it where this connects in here. Yeah, it's a interesting one, because every single tutorial that I've looked up on the internet on how to get one of these controllers to work with Arduino. Just connects it directly from the receiver to the Arduino, just directly connected. But that's 5 volts, and when I was reading through Mark W Tech's instructions, he said that he didn't have any trouble connecting it directly to 5 volts, but he was using a Logitech controller, and a lot of people who have been using the cheaper generic controllers were having trouble with the 5 volts blowing up the receiver or something. Now, I used the 3.3 converter straight away, so I don't think I damaged the receiver with 5 volts, but at this stage, who knows, it's probably toast, because I've tried it both ways, upside down, inside out, and can't get it to connect. So I'm just going to hope my new controller arrives today and works, and I guess I'll persist with that for the time being. Alright, well, fortunately, my next controller, my second controller, arrived in the mail today, so I'm going to crack that open and have a look. Probably start with a flathead. Now, hopefully, apologies for the 3D printer whirring away in the background again. I'm printing off the next phase of this project. Interesting board. Doesn't look terribly clean. Looks like it's probably been underwater at one stage. I don't know if that's just the appearance or what. Does look different from my original one slightly. There's a few minor differences. I wonder if they would connect to the other controller, or if it's just like this will only connect to that and this will only connect to that or something. I don't know. Well, here goes nothing. I'm gonna try and get this one to work and see how we go. What I might actually do, I might fire up, I don't know what I'm going to do. I was going to see if I could just program another Arduino just with a PlayStation controller code, just so I can get the controller working before I then load the whole thing onto the robot. So hopefully this one works better than that one. Although it's like bits of mask already just peeling away. Alright, we'll see how this goes. So I found this website, was it Arduino Project Hub, and they've got all the details on how to interface the PS2 controller with the Arduino. Got a little code, a little sketch for a test there, so I loaded this code onto an Arduino, and I didn't plug it in. I didn't plug the USB in, so it helps when you plug the USB in to the Arduino and then load the code onto it. Tips for the wise. Okay, now that it's in there, it's what it's doing is it's displaying back in the serial log there the coordinates of the X and the Y sticks. So you can see when I move the sticks, the coordinates change. So if I move the left stick, the left X and Y will change. And when I press the buttons, you can see I'm pressing the cross button comes up, triangle button comes up when I press the triangle button. while also reporting the position of the sticks as well. So I just test all the buttons, L2, R2, R1, L1 buttons, and so I'm happy. The PS2 controller is interfacing with the Arduino, and it's outputting a signal that the Arduino is reading on its serial. Is basically printing back into its serial interface, and that's good. It's good that that is going. So now that I'm happy that I've got a controller that actually works, I can load the full hexapod sketch onto my hexapod Arduino. This whole process has taken much longer than should have, I guess, and it's much longer than what I've actually filmed here. So if I've missed anything, I apologize. Alright, so now that I've got the controller working, I've just sort of mocked the receiver up here, plugged into my little shield on top there. You may notice that I have 6 connections here, not the 4 that I had earlier on, because stupid me forgot that you also need power and ground. Aside from the 4 signal wires, you also need power and ground. So yeah, I amended that slight oversight, and I've just got this mocked up just so that I can power on and test. Alright, powered on. I've still got the dongle sort of temporarily mounted there. I've got the controller powered up and synced. I've tested that it is receiving data. Let's go. Ooh. Oh, I don't want to walk too far because my desk isn't very wide. It's going to walk off the end of the desk. Ooh. That's cool. And down. Alright, I think I might have to call it for the electronics part of this project. I will neaten up this and obviously mount it on board. But yeah, we are good to go. When you are at rest, you will sit at the chair. Don't walk off the edge of the desk. Okay, so my apologies, this video has been incredibly long and dry, not incredibly interesting stuff with just the electronics. However, it is a necessary part of the project, and if you do like what is going on here, don't forget to, hey, subscribe, that's free. Hit that button, subscribe, it's fun, trust me. And also, shout outs to my supporters, those who have bought me a coffee from the Buy Me a Coffee link down there somewhere. We got Adam Hoy, Ray Brabants, and Jed Shane, all legends who have bought me a coffee. Thanks guys. Don't forget you can also buy a patch by hitting me up in the face page, and there is a patch. There's usually a patch on this desk, but I think the robot's knocked it off. Either way, you know what they look like. Thanks for watching. Apologies for the long and dry video, but I hope you're enjoying it. I'm enjoying it. I'm certainly having fun with this. I'd totally recommend this if you're new into 3D printing or electronics or both. There's a link in the description to all the files and everything for basically everything I've done so far. This next part is where I start to get bespoke. But so far everything I've done is pretty much off the Mark W Tech plan. Link in the description below. Big shout outs and big ups to Mark W Tech for this cool plan. Alright, peace.